Today's lesson is on two-step equations. It is very similar to solving one-step equations, except it will take us 2 steps to get our answer for our variable. Let's take a look at our steps. We can still draw a line down the equal sign, dividing the equation into a left and right side. We will ask ourselves what is happening to the variable. Like in this one, you can see we're multiplying the variable times 3 and then adding 5. To begin solving, we will work PEMDAS backwards. We will either be adding or subtracting first, or then we will be multiplying and dividing. So let's take a look at our example. You can see that since the equation was adding 5 to the variable, we need to do the opposite and subtract by 5 on both sides. Remember, your line will be drawn here if you need it just down from the equal sign. Once you have subtracted 5 on both sides, you can see these are going to cancel and equal 0. You're going to bring your 3x equals 15 straight down. Next, we'll do the inverse of step B. You can see we're multiplying x by 3, so we have to do the opposite and actually divide by 3. So you can see this line here means division. 3 divided by 3 is 1x, and 15 divided by 3 is 5. So 5 will be our answer, and I definitely want you to circle your answer. To check your answer, you're going to plug your answer 5 back into the original equation, and you can see I did that. I replaced x with a 5, and then I just followed the steps. 3 times 5 is 15, plus 5 is definitely 20. So you can see that we were correct in arriving at 5. So let's check out some examples and do them from beginning to end. The first thing you want to do is draw your line to separate your left side of the equation from your right side. You can see that I'm dividing x by 4 and then adding 9 in order to get 20. So to determine x, we want to do the opposite of PEMDAS. You want to start with either adding or subtracting. Since we were adding 9 to the variable, we want to do the exact opposite and subtract 9 on both sides of the equation. So I'm going to go ahead and draw my line. A positive 9 and a negative 9 is 0, so I'm going to cancel those out and bring down what's left. X divided by 4, the equal sign will still go here, and 20 take away 9 is 11. From here, for step B, our variable x is being divided by 4. Since we want to undo that, multiplication is the inverse or opposite of division. So we are going to multiply the left side by that 4 and multiply the right side by that same 4. These 4s cancel diagonally, and x is equal to 11 times 4, which is 44. Let's use this bottom space to actually check our answer. I will replace x with 44 in the original equation. So 44 over 4 plus 9, is that equal to 20? So let's do our math. According to PEMDAS, we would do 44 divided by 4 is 11, plus 9 is equal to 20. 11 plus 9 does happen to be 20, and so our left side equals our right side, so we know we're correct. So our answer is circled up here. Please make sure you circle your answer. Let's go on to the next problem. Here's our variable x, and my equal sign is here, so I'm just going to draw a little line that separates the left side from the right side. So now ask yourself, what are we doing to this variable? We're multiplying it times 2, and then we're subtracting it by 17. So we have to work PEMDAS backwards. So we start with the addition and subtraction. So I will add 17 to the left side and also to the right side. Negative 17 plus 17 is 0. So you can show me that. Just put a backslash through it. Bring down 2x and your equal sign. And let's add 45 plus 17. That would be 62. This represents multiplication, so we're going to undo that by dividing. Instead of 2 times x, we're going to divide x by that 2. When we get x by itself, because 2 divided by 2 is 1, remember we do not write a 1 in algebra. Next to the variable, it's invisible. 62 divided by 2 is 31. And let's give that a circle. Now let's check our answer. We're going to replace 31 in the first equation, up here the beginning one, with 31. There we go. Subtract 17 equals 45. So all I did was put our answer 31 in for that x, and you see that right here. Let's see if we came up with the correct answer. 2 times 31 is 62. Subtract 17 equals 45. 62 subtract 17 is in fact 45, so our left side equals our right side. We did it again. We are correct. Let's try a couple more problems. In this one, we have negative 8x plus 4 is equal to 36. So we want to start with this 4 and subtract it from both sides. If you still want to write that line, I suggest you do it until you're really used to doing these problems. 4 minus 4 is 0. Let's bring down the negative 8x. 36 take away 4 is 32. Now I'm going to divide both sides by that negative 8. Now I did that because negative 8 times x, the inverse would be dividing by negative 8. Negative 8 divided by negative 8 is a 1x, and 32 divided by negative 8 is a negative 4. I'm going to go ahead and check my answer. Again, you're going to replace your answer in the original equation for x. So that leaves us with negative 8 times negative 4 plus 4 is equal to 36. A negative times a negative is always a positive. So if I go ahead and finish my math, you can see that 32 plus 4 is in fact 36, which equals my right side. So I know I'm correct. In the next example, we will be starting by putting our line straight down with the equal sign. The variable x is right here. It looks like we're adding 11 to it and also multiplying by negative 2. So we want to do the opposite and subtract 11 from both sides. This is 0. We're going to bring negative 2x straight down. The equal sign, of course, is still here. And now this one is a little tricky. So if you want to write it out horizontally, negative 39 take away 11. You can see it's a subtraction problem. So if you want to apply KCC to this, you absolutely can. Keep, change, change. Now you can see negative 39 plus negative 11 is going to be equal to negative 50. Now we're going to undo this part. Negative 2 times x. The inverse would be to divide by negative 2 on both sides. A negative divided by a negative, of course, is a positive. And negative 2 divided by negative 2 is our 1x. And I'll circle that. Notice that sometimes the variable can actually be on the right side rather than the left side like the previous example, but you don't change any of your steps. Let's check our answer. So negative 39 in the original equation is equal to negative 2 times 25 plus 11. Let's see if we are right. Negative 39, negative 2 times 25 is a negative 50 plus 11. Negative 39 is equal to a negative 50 plus a positive 11 is in fact a negative 39. So we're definitely correct and we're good to go to the next few problems. In the next one, here's my equal sign. I'm going to draw a little line here. I can see my x is spotted right here, divided by negative 5 plus 10 equals negative 15. So I want to start with either adding or subtracting. The inverse of adding 10 would be to subtract 10 on both sides. That's equal to 0 because 10 minus 10 is 0. Let's bring down what is left. X over negative 5 equals. negative 15, subtract 10. Keep it, flip it, change it, is a negative 25. From here, we're going to go ahead and undo this operation, x divided by negative 5. The inverse would be to multiply by negative 5. So I'm going to multiply the left side by negative 5 and also the right side. Now for some of you, if you're curious as to why these cancel each other out, remember that that invisible 1 is underneath of this, so they do have common factors of negative 5. That leaves us with the x is equal to, a little math right here, negative 25 times a negative 5 is a positive 125. And again, you should always check your answer by replacing that answer that you came up with for the variable into the original equation. So I'm just going to go ahead and write that out. 125 divided by a negative 5, you should get a negative answer down here. And let's see what you should have. This right here is going to go into it negative 25 times plus 10 is equal to negative 15. When I add these two together, I do get a negative 15, so it does check out. So we are correct. The answer is 125. In the next example, draw your little line, subtract 4 on each side first. Those equal 0, which should be becoming pretty familiar to you by now. Negative 51, take away 4. Keep it, flip it, change it. You're applying KCC, and you get negative 55. Dividing by a negative 11 on both sides, x is equal to 5. And once again, you can go ahead and check your answer, and I will again do that. Negative 11 times 5 plus 4 equals negative 51. Negative 11 times 5 is negative 55, plus a positive 4 is definitely going to be a negative 51. So you can see it definitely checks out. We only have 4 more problems to go. So by now, you're probably getting the hang of this. So if you are stuck, I would definitely replay the video several times or pause it so you can go at your own speed. We're going to start by adding 3 to both sides of the equation. That leaves me with negative 5x equals a negative 24. Dividing both sides by negative 5, and this time we have an answer that doesn't divide evenly. So if you're utilizing your calculator, you probably figured out that it is 4.8, and that is correct. If you want to go ahead and check your answer, you can definitely do that below. In the next one, we're going to add 18 to both sides. This equals 0. We have x over 6 is equal to negative 20 plus a positive 18 is a negative 2. From here, you want to make sure you're undoing this operation, x divided by 6. The inverse or opposite would be to multiply by 6. So again, these cancel each other out, and x is equal to a negative 12. And again, you can also check your answer. I do know it's correct.